tool called optimization is the AO, and multi-language training is also really important. As an example, when DeepSeek back then was trained, they had two experiments. Where they trained in reasoning with instruct and once with base. And what was interesting is that, for example, the base version had like reasoning in multiple languages mixed. That also showed as an example that there are aspects of the English language, like Western languages, where we have like specific definition, or Turkish languages where you don't. I forgot what this was, but basically, like if you explain a state, it should use explain it directly or something in that direction. I'm not entirely sure what it was, but generally, what I'm trying to say is languages have different setups and have different structures on how they, for example, identify objects, assign something to a value, say explain what a state is, or if a state already has like a time fragment or not. And the thing is, what I think we will lead to is that we create an adapter between LLM and human language, and LLM state have their own language, which is highly optimized and, let's say, highly stateful. As an example, in the German, we have the term umfahren, and it either means drive around or drive over someone.
And it depends on the context.
Yeah, and even if how you say it.
Yeah.
Fahr ihn oder fahr ihn
Yeah, true. It's one of the jokes with the German language, but it's also very interesting how these LLMs understand, or like there is some level of emergence that happens with these LLMs, even though they are not trained on some languages, they get an understanding of that language, and also how each word is, like, spatially speaking, in different languages are roughly in the same position. So that is also very interesting. But as somebody who speaks 4 languages and I speak all 4 of them every single day, I can definitely say there are times and times again every single day that I want to say something, and there is no equivalent for it in one of these languages, so I have to borrow it from the other. And an LLM understanding all of them, I can imagine it just gives it a little bit more understanding, or like what did you call it, like states?
Yeah.
I don't understand the technicalities, but I'm assuming that there's some layer, some sort of, like, you've got an LLM is trained in like a foundational based language, but then it's potentially got like for lack of a better word, like a tool call or something that transforms the input language to the language of the LLM or something. Like, how does it do translation? Or could you quite possibly, do you train it to translate? Like,
right now, how LLMs are trained is literally you give the language in, it converts it to tokens, and it just spits tokens out. It doesn't do any translation in between, or like it converts it to embeddings, which are like just the numbers basically. It does like convert it to numbers, and then it gives us numbers out again, and they get converted back to text.
And the way the translation works, it's based on how can it translate a word from German to English?
I think that's just literally training data where we have like an English text is translated to German, and then the LLM got trained on it, and then basically based on that it does the translation.
So does that mean if there is a word that there is no translation for it, it won't be able to translate it? Or is there a level of emergence that it gets an understanding for it, even though that direct word is not translated directly?
I think it's a mix of both. First, you have to think about these LLMs have dictionaries, they have translation documents, they have a lot of data which already tested how to translate it. But I think there's also a small part of an emergence where it basically can understand the context and then use that context to also basically finish the translation of, even if with words it doesn't know. As an example, an interesting thing is you can make up a word and tell the LLM to translate it, and if it has literally zero context about it, or if it's, let's say, a new like young slang, it cannot translate it. It just copies the word with name, like name by name, because it just assumes it's a name. I mean, if you think about it, what's the difference between a normal word and a name?
Well, we can do this with Kavarza, because Kavarza is a made-up name. It is a name which is made of 2 words in a way, and it doesn't exist in dictionary. But if you tell it to a Kurdish guy, and especially if you pronounce it with the separation a little bit, they will understand that, okay, that means that, even though it's not a word in dictionary. But something also to add to the translation, which came to my mind, is interesting. We are thinking of this translation in a word to word from a language to another, but what these LLMs have tons of different languages and tons of different dictionaries. So theoretically, they can translate a word from a language to another through multiple languages in between, even though there is no direct translation between, let's say, German and English for a specific word. But there is, for example, from German to French and from French to Spanish and then from Spanish to English. So that way they figure it out,
I
because all
don't.
of it is in a same vector space.
It's in the same vector space, but I don't know if that vector space would necessarily get invoked if you just ask it to translate something. Maybe with reasoning models, but I am right now a bit doubtful that it would happen with normal models as well. It really depends. The issue is we still don't really understand how models even work.
Yeah.
And let's say the term house, right? In German it's Haus, in Turkish it's ev, or like home. The question is, how do you connect all of these terms? Like, how does the LLM actually generalize that all of these mean the same thing? That would be the thing we basically have to figure out, because then based on that,
Rosetta Stone.
yeah, like what is a home, what is a host, and how does it understand it in a multicultural aspect?
Is Chinese a really efficient language token wise? Like, is it worth identifying a language that's like, it's the least amount of tokens? Fuck German, because German is like the least efficient language in the but like maybe Chinese is just a really just from a token perspective. Yeah, what's that?
It's a design book called Grid Systems, Rastersysteme. It's in German and in English, both.
Yeah, it's twice as long in German, isn't it?
Not quite, but you can guess which column is German just by the length. Yeah. And the German words are longer, but that is such an interesting thing that you are talking about, because with German we also have this combination that you can make up any new word by combining multiple words together, and it's not like in English it feels like you're describing something with multiple words. In German it feels more specific because it's in one single word, and it's very pinned down.
And in LLMs, it's again different, because even we have our 26 I don't know how many letters there are, like 26, I don't know, base letters. Yeah. And the thing is, Chinese, first of all, has multiple variants. I'm not an expert on this thing, but for example, in like I don't know if Japanese and Chinese is in that aspect same, but basically you have like basically specific letters. And okay, let's talk about Japanese a bit. I have a little bit more knowledge about it. They have like three different, let's say, languages. Like different language variants, and they also have a lot of letter variants. Let's say with like the lines, and I just don't know, but you guys know what I mean. Like they have very characters, and the thing is, even depending on how you pronounce a character, it can have a totally different meaning. Regarding efficiency, what we LLMs generally do is, when we tokenize, let's say, a sentence, right? We don't need to take the individual letters. We always talk word fragments. Let's say hell or like or, like letter combinations which appear often. We convert them to a token. So when you say token efficient, I'm not entirely sure, because we basically expand the 26 letters into many letters to have as many combinations as possible and fill up like a specific set of parameters, which is running nicely up to 64. And I think in that regard, it doesn't matter, like in the token range, it doesn't really matter which language you use. It more matters how stateful the language is, I would say.
Yeah.
But I don't think it's what necessarily the language is doesn't matter. It's just like how this language grammatical and structural rules are constructed. I think that's the more important part. Not how many, let's say, base characters you have.
It could be that German is, in fact, a very efficient language because there's so much state in one word or one.
Germans are efficient.
I would actually say for LLMs, German, it may be efficient, but it also may be inefficient, because you have all of these complex words which are like unique, but then the LLM also has to learn all of them, and you have way less training data on each word. So the question would be like, how specific can you go before the LLM has too little context and just breaks apart?
Do LLMs face the same issue that we face with verbs in German that are it's a verb made of two words or like two half words, and it can get separated. So it's pretty difficult to wrap your heads around it. But you start the sentence by using half of the verb, and then you use the other half of the verb at the very end of the sentence. and it's a long sentence, you get to the end of the sentence and you get to the end verb, and you ask, wait, what was the base of the verb? So you, and it's very separated. So I'm thinking, like, does something like this even matter for LLMs? Because
I don't think the LLM will have much difficulty with that, because basically during the training process it's just like within a sentence it weighs like which terms are important, which is not important, and based on that it generates its understanding. I don't think it matters much if it's like side by side or if they're spaced apart. Also, if even if you, let's say we have a variant which is written together and a variant which is separated, what many tokenizers do, they have a word with a space in. So the variants without space and with space are two different tokens, and in the mind of the LLM, distinct words in that aspect.
okay,
If you want, we could also forward the LLM tokenizer and just play around, and I can show you what I mean. Write hello, and then write hello, hello together, and then write it once with a space.
4 tokens together.
Yeah.
Oh, still 4
You
tokens.
see how the color of the token changes, because oh wait, does it also show which numbers these tokens are? Yeah, these numbers, and if you show these numbers and now add the space, you see how the number changes. In the LLM, it's two distinct different tokens. And that's
Yeah,
also even for language efficiency. I mean, the entire term hello is 9906. Even if for us it's 5 letters, HELLO. And that's what I mean with, like, it depends on the tokenizer how efficient the language is.
Yeah. Very cool. Right, let's go to a break, and we'll get back with some Claude Code agents.